Hello, today let us talk about the frequency response curve of an amplifier. The frequency response curve is a graph plotted between the voltage gain of the amplifier and the frequency of the input signal to the amplifier. Now, a good amplifier should give constant voltage gain for all the frequencies at which it is to be used. അപ്പോൾ ഈ എല്ലാ ഫ്രീക്വൻസിയിലും ഒരുപോലെ ഗെയിൻ തരണം, അതിനാണ് പറയുന്നത് നല്ല ആംപ്ലിഫയർ എന്ന് പറയുന്നത്. ബട്ട് ഇറ്റ് ഡസൻ ഹാപ്പൻ ലൈക്ക് ദാറ്റ്. A typical frequency response curve of an amplifier is, I am drawing it here, shown here. So in the x-axis frequency, the horizontal axis frequency, and the vertical axis the voltage gain of the amplifier. So typical frequency response curve looks like this. So the voltage gain is constant at mid range of frequencies. So it is constant and maximum. Okay. So this is the maximum gain of the amplifier. So AM, we can write it AM. And the frequency reduces at a lower frequency. Sorry, the voltage gain reduces at a lower frequencies as well as high frequencies. So there are two frequencies, F1. You can define two frequencies, F1 and F2. This F1 is called a lower cutoff frequency, F2 is called upper cutoff frequencies. At these frequencies the power gain is F1 and F2. At these frequencies power gain become half the maximum value. Okay, so at mid range of frequency there will be maximum power gain. So at the lower cutoff frequency and upper cutoff frequency the power gain become half of the maximum. Okay, so these frequencies are called cutoff frequencies. So the difference between this is called the bandwidth of the amplifier. So bandwidth of the amplifier is the difference between the upper cutoff frequency and lower cutoff frequency. At F1 and F2 power gain is half, but the voltage gain is 1 by root 2, because power gain AP is equal to voltage gain into the current gain beta. Okay, so multiply by half on both sides, we will get this thing is AP by 2 is equal to 1 by 2 AV into beta. So we can divide this thing, we can make it AV by root 2 and beta by, okay, for current gain by 2, current gain, okay, is divided by root 2. So at upper cutoff frequency and lower cutoff frequencies the voltage gain become 1 by root 2 times the maximum value AM. Actually this is AM divided by root 2, AM of current gain divided by root 2. So at these frequencies it will become 1 by root 2 times AM. Okay, so this is the definition of upper cutoff frequency and lower cutoff frequency. Now, so that is at F1 and FL and FU, or F1 and F2, the gain, voltage gain become AM divided by root 2, which is equal to 0.707, okay, 70% of the maximum gain. Why the voltage gain reduced at lower frequencies and high frequencies? What are the reason? Okay, so we have two different reasons for these two. Okay, first one, at lower frequencies At lower frequencies, what happens? We know that the reactance of a capacitor is given by 1 divided by omega c, okay, which is equal to what is omega, angular frequency of the signal, and c is the capacitance of the capacitor used in the amplifier circuit. So 2 pi f omega equal to 2 pi f 2 pi f into c. Okay, so there are many capacitors we are using in amplifier circuit. ഒരുപാട് കപ്പാസിറ്ററുകൾ ഉപയോഗിക്കുന്നുണ്ട്. ഇൻപുട്ട് കപ്പാസിറ്റർ ഉണ്ട്, ഔട്ട്പുട്ട് കപ്പാസിറ്റർ ഉണ്ട്, കപ്ലിംഗ് കപ്പാസിറ്റർ ഉണ്ട്, സോറി ബൈപ്പാസ് കപ്പാസിറ്റേഴ്സ് ഉണ്ട്. അപ്പോൾ ഈ കപ്പാസിറ്ററിലൊക്കെ കറണ്ട് പോകുന്നു. അപ്പോൾ ഇൻപുട്ട് കറണ്ട് ഇതിലൂടെ പോകുന്നു. അപ്പോൾ ദിസ് കറണ്ട്, the reactance to this current is increases when frequency decreases. അപ്പോൾ ഫ്രീക്വൻസി കുറയുന്നോ, സിഗ്നലിന്റെ ഫ്രീക്വൻസി കുറയുമ്പോൾ റിയാക്ടൻസ് കൂടും. when reactance increases, the current to the transistor reduced. So therefore the gain of the transistor reduces, or the gain of the amplifier reduces. So when frequency decreases, the reactance, capacitive reactance increases. So the current the amplifier decreases. Okay, so the gain also, hence the gain decreases. Okay, so gain decreases like this. Now at high frequency, it is different reason. At high frequencies, okay, high frequency എന്താ സംഭവിക്കുക? So there is internal capacitance for the transistor. These capacitances are very small and become effective only at high frequencies. അപ്പോൾ ട്രാൻസിസ്റ്ററിന് ഒരു ഇന്റേണൽ കപ്പാസിറ്റൻസ് ഉണ്ടാവും. Normally that value is small, and at high frequencies this become effective. Okay, എന്ന് പറഞ്ഞാൽ ട്രാൻസിസ്റ്ററിൽ ബേസ് എമിറ്റർ ജംഗ്ഷൻ ഉണ്ട്, അവിടെ എന്താണ് ഇറ്റ് ഫോംസ് എ കപ്പാസിറ്റർ. ആ കപ്പാസിറ്റർ എഫക്റ്റീവ് ആവുന്നത് ഓൺലി അറ്റ് ഹൈ ഫ്രീക്വൻസി. അപ്പോൾ ഹൈ ഫ്രീക്വൻസിയിൽ ഇത് എഫക്റ്റീവ് ആവുന്നേരം some part of the input current is flowing through the capacitor as this capacitor, internal capacitor, as the displacement current. So some part of the input current flowing So some part of the input signal is flowing through the capacitor as internal capacitor as the displacement current. But only the conduction current, the normal current, the remaining part will be conduction current. Only the conduction current will be amplified. That is, the transistor amplifies only conduction current across the base emitter junction. So with the increase in the frequency, the displacement current increases. Okay, the displacement current increases at high frequencies. Therefore, the conduction current decreases, hence the gain of the amplifier decreases. So the transistor amplifies only conduction current, therefore gain of the amplifier decreases at high frequencies. So this is the reason for the reduction in the voltage gain at a lower and higher frequency range. Okay, so the transistor cannot be used for a frequency less than, or for an input signal of frequency less than this lower cutoff frequency, and for a signal of frequency greater than the upper cutoff frequency, and this range is called the bandwidth of the transistor. Okay.